In this section, we will look at some other valves commonly used in industry. One of these is the plug valve. The plug valve uses a handle to regulate flow. When the valve is open, fluid passes through an opening in the plug. A quarter turn of the handle rotates the plug 90 degrees and closes the valve. Because the flow travels in a straight line, there is very little resistance to flow through an open plug valve. Although plug valves are generally used for on-off service only, they can be equipped with an erosion-resistant plug that makes throttling service possible. A close fit between the plug and valve body is necessary to prevent leakage, but the close fit can result in excessive wear from friction. For this reason, plug valves have to be periodically lubricated. Another type of valve, called a ball valve, operates in much the same manner as a plug valve. It employs a ball with a circular hole to control flow. The ball rotates between two rings. In the open position, the flow is straight through. A quarter turn of the handle rotates the ball 90 degrees to close the valve. Ball valves are primarily for on-off service. In the throttling position, high fluid velocity will rapidly erode the partially exposed seat ring and the edge of the port opening. A ball valve, however, can be adapted with a special plug that makes throttling service possible. The plug is positioned off-center in relation to the seat ring so that it won't make contact with the seating surface until shutoff is complete. This allows equal flow around the full area of the plug even when the valve is only slightly open. Because flow and pressure are distributed equally across the plug, the valve can be throttled without excessive erosion. The operator can determine if the ball valve is open or closed by looking to see which way the groove at the top of the stem is pointing. When the valve is open, the groove runs parallel to the pipe. Closing the valve rotates the groove across the line of flow. Sometimes, however, the stem breaks away from the ball, so don't bet your life on the position of the stem. Use proper line breaking or blanking procedures and be skeptical around quarter-turn valves whose stems indicate they are closed. Here is a butterfly valve. Butterfly valves control flow by using a flat disc that rotates within the body of the valve. When fully open, the disc presents little resistance to the flow. A quarter turn of the handle, though, rotates the disc fully into the process stream and stops all flow. Butterfly valves can be used for both throttling and on-off service. Because dynamic forces develop across throttling butterfly valves, they should always be latched into the throttling position to prevent them from slamming open or closed. Nearly all the throttling capability occurs in the first 30 degrees of rotation, so be aware that there may still be a lot of flow through a butterfly valve that is only 1 or 2 notches open. Here's a valve that doesn't use a plug or a disc to control flow. It's called a diaphragm valve. Flow is controlled by a plunger that moves a flexible diaphragm up and down in relation to a weir or seat. The diaphragm forms a seal that prevents fluids in the line from entering the working parts of the valve. So, this type of valve is ideal for handling corrosive fluids, sticky materials, or other substances that require high purity. Valves that control flow direction rather than flow rate are called check valves. Although check valves come in many different designs, they all provide the same basic service, which is to prevent the reversal of flow in piping systems. This is a swing check valve. The disc is free to move on its pivot pin either toward or away from the valve seat. As long as the flow is from A to B, the disc will flip away from the seat and allow fluid to pass through the valve. If the flow were to reverse itself, the disc would swing down and close the valve. In the lift-check valve, the disc and seat design is similar to the design of a globe valve. As flow occurs from A to B, the disc moves upward. But if flow stops or reverses itself, the disc moves down and closes the valve. So, lift-check valves also control direction of flow. Because gravity pulls the disc downward when flow stops, a lift-check valve cannot be installed vertically or in any other position where gravity cannot do its work. If installed vertically, the valve will still admit flow, but it will not close if the flow direction changes. For this reason, this type of valve is called the horizontal lift-check valve. This is a vertical lift-check valve. When the flow from A to B stops, the disc drops back to its seat. Flow from B to A can't occur. The vertical lift-check valve can't be installed horizontally. Flow, pressure, and gravity also operate ball-check valves. Instead of a disc or gate, a ball controls the opening of this valve. Ball-check valves are manufactured in both horizontal and vertical designs. Now, it's time to review the material we've just covered. Please stop the tape and turn to work.